Hello there, it's Ken Gitari. Uh, Today we're going to expand this expression. This is a binomial expression. That's 2p minus 3q to the power 5. But before we do that, I'm going to write down a general formula for binomial expansion. Here, I'm going to just write it down and I'm going to explain it a little bit. Yeah, there you go. So we're going to use a plus b to the power n. Now, with binomial expansion, there's a general formula. As you can see, these figures, these values in brackets, these are coefficients, and actually derived from the Pascal's triangle. Second thing you note is that the powers of A start with n, and then keep on decreasing by 1. So you got n, 8 to the power n, 8 to the power n minus 1, 8 to the power n minus 2, and last 8 to the power 1, and then 8 to the power 0. You keep on decreasing. Whereas the values of b starts with 0, keep on increasing by 1. So b to the power 1, power 0, b to the power 1, b to the power 2, goes on up to b to the power n minus 1, and then b to the power n. So that's what we're going to follow. And these values are combinations. You can get them from the calculator. There's a function here, combination formula. But now let's try to expand that one. So we got 2p minus 3. I'm just going to write it down, and then we are going to simplify it. Before we write it down, we can use those that we can actually check for the combinations from here, but I'm going to use the Pascal's method. So I'm just going to just get the coefficients straight from the Pascal's method, Pascal's triangle. And anything in an expansion to the power 5, the coefficients are, I'm just going to write it down here. Let me put it here. 1, 5, 10, 10, 5, 1. 1, 5, 10, 10, 5, 1. So let's put it down now. Put it 1 there, and then we got x is 5. Okay, I've written it down. So let's check whether I've written it correctly. So that's got the 1 there, the coefficient there, got 5, we got 10, another 10, we got 5, and we got 1. So I think that's correct. Secondly, we got 2p to the power 5, you can keep on checking that. The power 5, 4, 3, 2, 1, and 0. That's the powers of 2p. Powers of negative 3q starts with 0. We got 1, 2, 3, 4, 5. And so far we're good. Now what we need to do now is to simplify the expression. So here we go. So we're going to start with that. This one will just disappear. This one will disappear because any value raised to the power 0 is just 1. So we got 2p to the power 5. 2 to the power 5 is 32, and then p to the power 5 is, so that will be 32 p to the power 5. When the power 2p to the power 5 is 2p to the power 5 first, and then p to the power 5 second. So we got 32 p 5 to the power 5. So we got this one here. First, we need to check this negative sign here. Because the power is odd, that means the whole expression, you have a negative sign. So that is minus. So 3, let's do this. P, that's 2 to the power 4 is 16. 16 times 5 is 80, multiplied by 3, that is 240. And then we got p to the power 4. And then q. That's q to the power 1, is just q. So you got the next one here. This one is a negative sign here, negative 3q, raised to an even number. That means the final sign will be positive. So we got positive here. And we got 3 squared, that's 9. 2 to the power 3 is 8, so 8 times 9 is 72, multiplied by 10, that's 720. 720 p to the power 3. Q to the power 2 here. Let's got this one here. So here we got a negative sign there, raised to an odd number, and therefore the sign here will be negative. So minus 3 to the power 3 is 27. 27, and you got 2 to the power 2 is 4. 27 times 4, that's 108, multiplied by 10, that's 1080. And then you got p squared. And got q to the power 3. We're going. Good. Come with me. And then we got this value here. With this a negative sign raised to an even number 4, and therefore this will be a plus. So negative 3 to the power 4 is the same negative 3 squared, then squared again. So that's 9 times 9. That is 81. 81 times 5 times 2 is 10. 81 times 10 is 810. So you got 810. P to the power 1 is just p. And then q to the power 4. And let's do the last one. The last one here, this will disappear. It's just 1, and value raised to the power 0 is 1. We've got negative 3. That means that would be a negative because it's raised to an odd power, negative. And it's negative 3 to the power 5, that's 343. Q, power 5. I think we've done the expression. That's, as you can see now, because of the values which are 2 and 3 in here, the final coefficients are not the same as the Pascal's triangle. All right, so that's the final answer. And what I want you to do now, can you please try to do this one for me and put it in the comment section. I want you to do this exercise. That's 2x. Let's put it simplified. I want you to do this one for me. 2x minus 3 to the power 4. I want you to use these coefficients, that Pascal's, these coefficients, binomial coefficients, 1, 4, 6, 4, 1. When a binomial is raised to the power 4, those will be the coefficients, like these ones. Do it and then put it in the comment section. Thank you very much. See you next time.